US. So now today we will talk about relations and functions. And functions is the introduction chapter for calculus, and it's class 12, chapter 1, Cbse, according to Cbse, and it's mathematics. And relations and functions, it's a very easy chapter, and we can discover many things, and we would make many discoveries, and like discussions would happen right now. Okay, so with a small shloka we would like to start, and that shloka would be Saraswati Namastubhyam Varteya Kamarupini Vidyarambham Karishyami Siddhirbhavatu Me Sada. Okay, with this positive shloka, we are going to start today's class. Okay, so relations and functions. To understand this relation and function, we need to know first what is relations. Relation, we have relation with our family members. We say that in any wedding, we should invite all our friends and relatives. So they use the word relations. We have a relation of many things, relation of teacher and student, relation of father son, and many more. Function, what we say is function is something like a process. With process I mean very simple thing, meaning that if there is an input given to that function, it would give us an output. Okay, so that is input and output. That's a simple definition of function. Okay, so as here we are able to see Lejeune Dirichlet has discovered this relations and functions. So to start with this, we need to know what are Cartesian products, and then how we came from, how we are, what is the need of relations and functions, why we need to study relations and functions, and why is it important to know this. So first, relations and functions. Relations, I said it's a relation between me and you. So how can we specify it? If I write like this, I am making a circle. Okay, if I am making a circle like this, okay, and two circles. If I name this A and B, a simple name we can give it any. Okay, A and B. If you are able to see my screen, A and B. Okay, so here if you are able to see A and B, then there are many students, and there is only and there are 6 teachers of the 6 different subjects. Okay, so 6 subjects, and so every student of here, all these 40 students have a relation with the first teacher, relation with the second teacher, relation with the third teacher, and relation with the fourth, relation with the fifth, relation with the sixth. Or you can say, so this was a simple definition that we are making. Now how to define this relations and functions. We can define if there be 2 non-empty sets A and B, then and if there exists a relation R, we take relation as R, then they are considered to be relation. It's very simple. Then they are in relation. But this was that I told you about relation. But to know relation, we need to know what is Cartesian product. And Cartesian product, as the word suggests, it's the same thing as relations and functions. Okay, so if there are 2 non-empty sets A and B, again this circle. Okay, so if I take 1, 2, 3 here, A, B, C here. Okay, so then what the main thing the topic says is that if 1, we would multiply. Cartesian product says 1 comma A, then 1 comma B. If A has 1, 2, 3, and the second set B has A, B, and C. If I am letting these both are non-empty sets and everything. Okay, so 1 comma A first, then 1 comma B, then 1 comma C, then 2 comma A, 2 comma B, 2 comma C, 3 comma A, 3 comma B, 3 comma C, and all these sets would be when combined together in a specific set. That set that we, in simple words, in set theory we call that as power set, PA. If it's A, then it will be PA. But here in Cartesian product, when we are Cartesianally producting them or multiplying them, then what we do is very simple, as I told here. Okay, so this was the basis and starting. Now moving further, we should now know that what should be like I hear if one has a relation of brother with this, sister with this, father with this. I am just giving an example. It's his brother, his sister, mother, father, like this, and they have a relation. Okay, so like this, and they have a relation. So this would be a relation only when one has a relation with A or B or C. It has to be a relation. Okay, so starting with in the first thing that we should know is the three important topics, that is reflexive, symmetric, and transitive. These three topics, these three are the types of you can say relations. And what is reflexive? Okay, so reflexive, to know reflexive, as I told you what was Cartesian product, we should know what is a normal ordered pair. Ordered pair. What is the word naming? Ordered, meaning it is ordered. Like if it is A comma B, then it is different. It is different from a not equal to B comma A. That is ordered pair. Okay, so in associativity, commutativity especially, we say A plus B equal to B plus C. But not in this ordered pair. It is ordered. Okay, we cannot change the order. That is ordered pair. Okay, to know that we should know this term ordered pair. Then only we can understand reflexive. Now reflexive. My students mainly people ask also about these questions, so I am starting with this. Okay, reflexive. Now what is reflexive? In physics we have studied this word reflexive, and what we had known there was that reflexive is when a mirror reflects at light, then that's a reflection. So it's here also somewhat relative to this. Okay, so reflexive is if A and B belongs to is E, capital E. Okay, if A and B belongs to a set A, if we take a set A, okay, then A belongs to set A. If only A belongs to set A, then if we are able to prove by that relation there exists a relation R, there we should write this in notebook also. There exists a relation R that says that relation R from A to A, from set A to set A, meaning okay, set A from set A to set A, and then there should be at least one point that should be A comma A. And if there is A comma A, okay, if A belongs to set A, then if we are able to prove that A comma A belongs to R R is relation of set A to A, okay, then A comma A would be reflexive. Then this relation we can call it a reflexive relation. Okay, done. Nothing else. This was reflexive. Now comes symmetric. Now, as the word suggests, like everything, symmetry. What we do symmetry? We draw a line, and then if it is able to bisect that figure in equal angles at that figure, then it in two halves, then that's a symmetrical line. And here also it's something what same. If A comma B, we can say A and B exists. If there is A and B belongs to set A, the same. If there exists a relation R where A is set A to set A only, and it is given from the question that A comma B, or it is given in the question that A comma B belongs to R means relation, then B comma A would also belong to relation. We should prove that B comma A belongs to relation. If we are able to prove this, then it's symmetric, or else if we are not able to prove this, then it's not symmetric. Okay, that was our two things, reflexive, symmetric, and the third last one, that's transitive. Transitive is about three things. So transitive, okay, it's transitively, transitive. Now transitive, as the word is also suggesting, that if A, B and C, three terms, first we are talking about only A, second we talk about A and B, now we are talking about three. If A, B and C belongs to A, okay, then same, if there exists a relation R from set A to set A, then if it in the question it is given that A comma B belongs to R, B comma C belongs to R, and if we are able to prove that A comma C exists, meaning it's in a relation R, then it is transitive, or else it is not transitive. Okay. So in these three things, you will now be able to easily understand that odd-wise ordered pair necessary. Okay, now so you are able to see also here. So these were the three types of relation: reflexive, symmetric and transitive. And now moving further is now equivalent relation. Equivalent relation is nothing. If it is transitive, symmetric and reflexive, then that relation would be called as equivalent relation. Why equivalence relation? Because it contains all the three. So we call it as equivalence relation. Okay, so these were about the first thing, and about relation and functions. So this was, I was talking about relations, functions, and I defined it also what is a relation R and everything. Okay, so now our next topic from this would be, what are functions? Okay, so functions we would now start. Okay, so many persons have many definitions. First, going to the point, the definition says, first I should, for definition of function also, we need to define some points. Then only we can understand what are functions. What you are making in the starting, the relations, I said A and B are two non-empty sets. Okay, now I would name this. The first one would be pre-image, before image, and the second one would be image, okay, pure image. And pre-image, image, okay, and this pre-image would be domain, and image would be codomain. Okay, if we are clear till here, then we are easily defined. Okay, now we would say every element in the domain, or you can say pre-image, in brackets you can write pre-image. Every element in the domain has a unique, brackets, one and only one image. One and only one. There's only one image, meaning that it has only one image. Okay, so I can define every element in the domain has unique image in the codomain. Okay, unique means one and only one image. This is a simple definition of functions, and to understand us, we should say that function is a special type of relation, because the relation is so vast. It is that it should A and B should be non-empty sets. Then there is a relation between them. Okay, so that was relation. It's too vast. But functions is not too vast. If they're in the domain, it is like father and son. And if we consider pre-image as son, then this is father. Okay, so father, son. This is the main concept. Okay, so why we are considering this as son? Okay, so every son would have unique and one and only one image of one and only one father. I cannot have two fathers. I would only have one father. Okay, and this father, one father can have two sons. Okay, that's possible that if I take 1, 2, 3 in the pre-image and A, B, C, D in the dome. I will give you every examples. Okay, 1, 2, 3, A, B, C, D. 1, 2, 3 is domain and ABCD is codomain. Okay, so now as we are able to see, it's clearly mentioned